Okay, this is our 6th lesson of Chapter 7. This lesson does not fit in with the rest of the chapter. I will not lie to you. It totally kind of takes a turn to a different direction, but it's not super hard, and it does kind of have a geometry application. It's called scale models and scale drawings. Let's get started with some vocab. First is a scale model. A scale model is a 3D reproduction of an item that is made to be proportional to the original. So the big idea behind a scale model is that it's 3D. You can kind of hold it in your hand, or it's, has that third dimension to it. Scale drawings are very similar to a scale model, but it's a drawing. It's two-dimensional, and it's made to be proportional to the original. So the big idea is that it's proportionally created. And that means that I'm not just drawing a little smiley face stick figure guy and saying, yeah, that's a scale model or a scale drawing. A scale drawing actually has a lot of math that goes into it to help you calculate exactly how tall the person would need to be, how long his arms would need to be, how long his legs would need to be, and a whole bunch of other mathematical details. The ratio that we use to make a scale drawing or a scale model is called the scale factor. Okay, so the scale factor is the math that goes into creating these drawings and models. Okay, so I want you to really quickly think about Hot Wheels or Matchbox cars. If you ever had one or have them, you know that they're really cool and they look just like the original or what they're supposed to look like. And that's because a lot of math went into creating that model. If you look at a brand new Hot Wheels package, it will tell you the model that was used to create that, or the scale factor that was used to create that model. So that's pretty cool. A lot of math goes into this stuff, and it's not such hard math. Our last note for the chapter before we go into some examples, scale models and scale drawings are made to be proportional. You saw me talk about that a couple times already today. So proportional, that tells us that we will be writing a proportion and we'll be doing some cross multiplying to solve. I also want you to please write this in your notes, model over real. When we create our proportions, we want to use this format. The model we want to put on the top, and the real we want to put on the bottom. And that's usually how a key or a scale is given to us anyways. That just kind of helps us to all be on the same page. Let's do our first example. A scooter is 3 1/2 feet long. That is its real life measurement. Find the length of a scale model. So we're looking for the M, the model length. If the scale is 1 inch equals 3/4 feet. So this is the scale that was used to create the model. We're going to find the length of that model now. Okay, this is slightly different than a scale factor, just so you know. This is called the scale. We're going to talk about scale factors in just a minute. So the first thing we want to do is we want to take that scale and we want to write it 1 inch over 3/4 feet. And that is, remember what we talked about in the last slide, that is our model over real. That is the 1 inch here represents 1 inch in the model, and that is equal to 3/4 feet in real life. So that is already set up in that order. Now we need to figure out where to put this 3 1/2 feet. Well, 3 1/2 is the real life length of the scooter, so we're going to put that down here with the real life measurements, 3 1/2 feet. We're going to use an X to represent the model length of that scooter, okay? So now we're going to go and we're going to cross multiply, and we get 3/4 X equals 1 times 3 1/2 is 3 1/2. So we have to divide both sides by 3/4 to get the X isolated, and here's where we need to use our complex fraction. This is where we need to do a little bit of fancy mathematics. 3 1/2, we have to turn it into an improper fraction. 3 times 2 is 6, plus 1 is 7. So we get 7 over 2 divided by 3/4. Outers first, we get 7 times 4 is 28. Inners is 2 times 6, or 2 times 3, and that's 6. So there's our answer. It's just not in final answer form yet. 28/6. We're going to drop the 28 into the house. 6 and 28 4 times, with a remainder of 4. So that remainder is our numerator and the 6 is our denominator. Still not quite finished. We can divide by 2 to simplify this fraction. We get 4 2/3 for the length of the model. Well, what measurements are we using? Should we be using inches or feet? This is x. X was up here across from our inches, so our final answer is 4 2/3 inches. Okay? So basically it's just setting up a proportion and cross multiplying. Let's see another one. Miss Sainer assigned you a project to create a scale drawing of your bedroom. She suggests that you use a scale of 2 inches to 3 feet. So she's telling you that's a good scale to get it to fit on the size paper she's giving you. In your drawing, the width of your bedroom is 15 inches. What is the actual width of your room? So we're looking for the real. We know the model length, or in this case, the drawing length. So we start with our scale. 2 inches in the model represents 3 feet in real life. We don't know the real life length, but we know that your drawing is going to be 15 inches. So we put the 15 here where the model goes, and we're looking for the real life measurement. So we're going to cross multiply. 2 times x is 2x. Bring down your equal sign. 3 times 15 is 45. We're going to divide by 2 on both sides to get that x isolated. And we get 45 over 2. So we can do a real fast division here. Drop that 45 into the house. 2 goes into 4 twice. 2 goes into 5 twice. 1 is your remainder. So we get 22 1/2. And then we're trying to say, okay, well, what are our units right now? What are our units? We're looking for the real measurement of our room, so that's measured in feet. 22.5 feet is the length of your bedroom. Okay. One last example. We haven't done anything with scale factors yet. So basically, we're going to talk about how to solve a scale factor now. So we've given you scales. This thing here is a scale, and it tells you the relationship between the model and the real. But if we want to find a true scale factor, we have to do a little bit of fancy math here. And we're going to start off by taking our scale and writing it model over real. 1 inch in the model represents 6 feet in real life. Now, to make this a true scale model, we need to get both of these in the same units. So we need to change our feet into inches. So feet to inches, I know that means that there are 12 inches in 1 foot. So 6 times 12 tells me there are 72 inches in 6 feet. Now, I'm not going to multiply the top by 12 because that's already in inches. So I didn't change the meaning of my fraction. I just took my denominator and I said, you know what? Feet and inches are a nice little conversion. I can multiply by 12. And now I have this ratio of 1 inch to 72 inches. If I want to turn this into a true scale factor, I get rid of the inches and I just write it as a ratio 1 to 72. That tells me that the model sailboat is 1/72 the size of the real thing. Or 72 model boats end to end would match up to be the length of one real sailboat. It's pretty small, 1/72. So to find your scale factor, get both your units in the same measurement units, and then you can drop them, and you have a ratio. Okay, this is probably the trickiest part of this lesson, so we'll talk more about this in class tomorrow. Go ahead and do your practice problems and ask questions in class tomorrow.